Sure. Hey, hi all. Welcome to the class. I am going to be sharing my screen. There we go. So let's have a quick look at our syllabus just to see where we are, what we've covered, and what we'll be looking at now. So, all right. So we've done these topics. We've covered everything till week 7. So we're currently in this, the revision of the previous topic. So this was basically put there just in case if you're moving ahead of what we can catch up with, or if you're having any places where we're getting stuck, to have some discussion. But the next topic we'd be covering as far as the course goes is a bit on hypothesis testing. These are like some standard statistics stuff that everyone is usually expected to know a little bit. This is a continuation of that again. This is the concept of confidence intervals. A lot of standard packages like Tableau or a lot of things have these sometimes encoded in a way that you can just click and get the stuff done. You don't even have to write code for it. But even if you write code, it's going to be like one line of code to do the hypothesis test or build the interval. But you might always do some data gathering and cleaning kind of thing before and after calling that function. But then there would be some summary of results. You should also be able to understand how to interpret the summary. Most of the results can have returned what is known as a p-value. There's some summary. And this kind of question actually came up when we were doing linear regression in the very beginning of the course. Some of you asked me how to interpret the output that R is throwing out. We interpreted different parts of it. We talked about R squared, different parts of the output, but there was some part that dealt with the hypothesis test and intervals. That was the part that I said we'd be ready to interpret once we go over these two topics. But because these kind of results show up a lot of times when you do different things. And then we have a very useful topic from an applied perspective in the future, the clustering. It's a very standard problem. It's very useful in real life, so in industrial settings. So a bit on that, and then some on other classical topics. So what's happening is maybe, K-means is more classical, but spectral clustering is more like slightly newer technique. Other than that, week 9, 10, a bit of 11, and mostly 12, 9, 10, and 12 are mostly covering classical topics. So these are kind of prerequisites everyone needs to have in the back of their head so that you're not taken aback in the future when you face these topics here and there. They usually show up very often. And anything that we covered before week 8 is kind of solid machine learning stuff. This is very useful. Like you have the real solid techniques here, the more powerful techniques like SVM, random forest neural network, and how to evaluate these using these different metrics, etc., etc. That's it. And then we have the advanced course for people who want to go to it. We can discuss that separately. Okay, so some things before I get into the hypothesis testing topics. Any questions? I see I got some questions on the project from Thiru. Let's go over that. So what's today? Okay, she's using random forest. You're using So when you say you can change the entry parameter, you mean when you change the entries, it's not making any much of a difference in the output and the error and all that? Is that what you meant to do? I see.
I gave them a different entries, but then when I print a random forest summary, it just shows me that it is using only 500 trees, though I give a different number.
Oh, okay. So it's using the default. Okay, I will look into this. I will email back on that quickly today. And then the other thing, let's see, just so that I get your consent. Difference in model performance by changing mtry. Okay, you see a difference in the performance when you change the mtry parameter, but oh, I see. Yeah, so this question is kind of relative, right? So how is the difference very rapid when you change from mtry from one number to other, the neighboring number, like from say 3 to 4 or 4 to 5? Is it changing a lot, or if the improvement is very little, then you don't have to bother much about it? If it's changing a lot, and if you have some time, you can obviously try to tune some more.
No, all I'm wondering is if there would be any change if I change the entries, because after 8, it's showing the same values. It's kind of giving me the same means per error. Everything is kind of, it's almost same after 8.
Okay, so got it. So yeah, so
Random forests entries usually is not a very important parameter unless you're using too few trees. If you're using a few hundred trees and more, it won't change much. And also, it's good to tell that if you compare random forest versus SVM in terms of parameter tuning, random forest is not as sensitive to its performance is not very sensitive to your choice of parameters. Choice of parameters is important, but not very sensitive to it. SVM is kind of a lot more sensitive. Like you need to have the right cost and gamma. You should be at least in the right direction, in the ballpark, to get some good performance. So yeah, you don't have to worry too much about entries actually. The most people try is maybe 1,000 or 2,000 in these kind of data sets. And that basically just takes more time to run. That's the difference. It wouldn't give much of a difference in your performance. Unless you're doing like 50 trees or 20 trees, then then it's a bad thing. As long as you're above some threshold, it should be okay. So that's the thing. But I will still see why it's not updated, why it's taking the default, just in case. Because you should at least be able to do it if you need it in the future. And you're using the Parkinson's data. So this is not like a very easy data set in terms of being able to predict with high accuracy, but nevertheless, still worth the exercise, right? In the future, all that will change your data set. So your report seems to be in a good, like shaping nicely. The code looks very nice. So this will definitely get into your resume like a good project. You can mention all the random forest in your project title and all that. So any other questions? I've not got any other project updates from other people, but do you want to do it quick so that? Yeah.
Hey Praneeth, this is Kamal here.
Oh yeah, Kamal.
I'm stuck with the soft impute method. Screen.
I see. So have you sent any email by chance or?
No, not yet.
Okay. I was just making sure I did not forget it. Thank you.
Yeah.
Okay. So you're trying to
the soft impute method will get that D and D variables, right?
Yes.
How to get back to that? I mean, it's
the original form.
Okay. The version. Yeah. So I was using complete, and it was kind of an error with that.
Sure. So what it is returning is one has the singular vectors. There is in linear algebra and matrix algebra, there is something called eigen decomposition. There is SVD, singular value decomposition.
Yeah.
So what it is returning is the singular vector. So you can see my different tabs, right? I'm sharing all.
Yeah.
Okay. So you have to just do U times D times UDV transpose. Also, this is like matrix multiplication. So in R, the matrix multiplication, instead of putting a dot or star, you have to do something like percentage star percentage, right? Okay,
right.
I bet I told this before, but yeah, percentage star asterisk percentage. We'll instead do matrix multiplication. So you have to put this thing every time between U and D, and then between D. You start like this and then go. So you start from here. You multiply D and V with matrix multiplication, and whatever you get, you store it somewhere, then you multiply these two. Then you get it in the original form.
Okay.
Yeah, one thing you might want to verify, right, when you do matrix multiplication, your dimensions should match. So if this is n by n, if D was n by n, this should be matching n by whatever.
Yeah.
And, yeah. So just check the dimension, because maybe it is already giving you in the transpose form. Based on that, you may or may not require to transpose. But the thing is, you have to multiply UD, and UD has to be in the middle. That's the point. Yeah.
But we need to multiply it.
Yes. I actually have some. Did I send you any soft impute code?
No.
Okay.
In the couple of examples that I Googled, they were using complete. The same complete function, it wasn't working for me.
Complete for doing
yeah, I have a few NA values in there. NA values.
Yeah. So by the way, the complete is, yeah, that is not the recommended function for imputation though. You can,
Okay.
if you want to do something simpler than soft impute, because soft impute might require some tuning of parameters. But if you want to do something simpler, I would usually recommend KNN impute.
Yeah, I did that too. This is just I'm doing 3 kinds of imputes. One is KNN, mice, and soft impute.
Oh, very nice. Good.
That is
Yeah.
all.
So yeah, if you see here, the transpose does exist. So you're getting U, D, and V. So it's UDV transpose like I wrote, and I'm doing percentage dot. You can see my thing, right?
Yeah, I do.
Yeah, yeah. So that will give you the final imputed version. Okay, cool. All right. So yeah, let's see. Anything else?
Brilliant.
Okay. So this should form a project for you for sure. So
yeah.
Let's just keep at it. Cool. So all right. So moving along, Manideep, anything you wanna bring up with the project especially?
I have something like that auto MPG project going on. I'll share the details soon, Pranit.
Sure.
I have to send you an update on it. Yeah.
Okay. Yeah. Sure. Yeah. Okay. Good. Manish.
Hey, Pranit, I actually applied like impute, KNN impute, and I did. I mean, missing values and all that I've done, and then I've uploaded. I've used SVM and tuned a little, but this apply center scale ZV and NZV removal. Can you just give a small brief on those? The numeric variables.
Sure. I mentioned this in the doc, I guess, right?
Yeah. It's there in the doc. So yeah, until that I've done, then I've applied this SVM. Then I'm planning to do other imputes and apply all the other techniques.
Got it. Okay, got it. That's update. Cool. So yeah, I will. Yeah, I just wanted to see what I put in the doc once again so that I cover that line.
Yeah, it's at numeric variables point.
Oh yeah. Okay. Oh, okay. Sure. Yeah. So pre-processing. I see.
Yeah.
So the easier one to explain first is the zero value remove, zero variance and near zero variance.
Okay.
Yeah. Okay. Yeah. Okay. So basically, if your data set has some columns, some features which are completely constant, like whatever row you put in that those columns is the same value.
Is it the complete row that is repeating, or the specific
column is repeating? So
the specific
column, yeah. So unless you're doing like something with genetic data or like genomics, which we are not doing, right? It's not like bioinformatics kind of an application. So unless that is the case, for everything else, usually the format is like this in the real world most of the time. N by P, where the number of rows, if you have N rows and P columns in your data set, the rows are basically your samples.
Okay.
The columns are your features or your variables. Standard.
Yeah.
Like this. Business terminology or whatever, economic terminology. So yeah, if your column is constant, so maybe, so by the way, what is sample? Sample is the one you're trying to predict some column or classify some column, right? Some value, 0, 1, whatever it is you want to classify, or you want to do prediction of some real number. So these could be like different people, you're trying to predict something about that person, right? Or different emails. Now, the column is constant sometimes, which means it's basically a useless column because, say, I took some data set and I have some age column. One column is called age. And if, say, everyone in my data set is same age, 30 years or whatever, 40 years, right? Everything is exactly the same. That variable is not giving me any information in trying to separate that person between class 0 or class 1. One type of person, it does not help me at all, right? So there sometimes you'll have some variables which will be completely constant, which are basically more of a headache to your model, because your model implicitly might attach some coefficient or some number in the equations to that column as well. So it's basically a waste of, so it's basically make your model perform less optimally than it should.
But what if those two columns have different labels? Like if that variable is representing something different than
there is only one. But yeah, of course the labels will be different, right? The rest of the columns are changing. So
okay.
Label. But just by telling age is 30, it is really hard to predict whether the person is a high performer in the class or a bad performer in the class. Or if the person is going to be a defaulter for the bank if you give him a loan, or if he will pay back his loan. Just by saying age 30, every time you cannot separate the different people.
Okay.
There is no signal in this. There is no information in this basically to take any decision. Just by saying if all people have same name, like these are cartoon data set.
It's just like we see when we say summary on the summary function in R, it will give us some stars to the labels, right? Like this is important, this is not important. It's doing something like that.
That is after you fit the model. Yeah, true. After you fit the model. Say you do linear regression, for example. It's simple model, linear regression, right? And say you have a column that is constant. So then you will predict output as like this, right? Some beta 1 coefficient of x times x1, which is the first variable, plus beta 2 times second variable, plus so on, right?
Yeah.
Now say if x2 was the culprit, it was the zero variance, the constant column, for example, if this was the constant one. The thing is, linear regression, it will give you B2 some small number, but it will still give some number to it. It will not give 0. It might give some small number, 0.001 or something, 1, 2, whatever. Okay. When you do summary, it will show all the coefficients, what beta 1, beta 2. If beta 2 was 0, then well and good. You are not using that variable, so your model is predicting better. But if you are giving it some number, it is just an offset, right? So it is not required basically. So you cannot force it to give 0. It will give in the end when you do the summary, it will say this was not significant, but your model that you learned has already learned beta 2. So when you do prediction with it, it will always use beta 2 as well. It is only giving you as a retrospective. After you used it, it will tell you that it is not significant, but your model that you trained already has used it. So if you want to drop it so that it will not use it as part of the trained model before you go to the prediction stage, then you have to remove it in pre-processing. This gets a little more complicated because here it's a simple model. If you go to SVM and all that, then basically it is using a useless variable many times. So it is not giving you predictions, adding more noise to your predictions.
Okay, thanks.
Cool. Okay, cool. So any other questions, Manish?
Oh, that's it, Pranit. I was just seeing what are those things doing. So center, scale. I mean, I think basically all are the same. I'll go through them. Yeah,
the center and scale is different. ZEV and NZ we discussed now. Center and scale is basically different. Center is making sure that you move all your variables. If you plot like this, they're similar shape, for example. I didn't draw properly. But they're centered at different points, right? So center is going to subtract the mean from each variable. So this variable, it will subtract this particular value from all values in this variable. All values in this variable. So all rows in this variable, in this column, it will subtract this value. So it will make sure after centering, all your data points always have a mean of 0.
Oh, cool.
So they're comparable. The shape stays the same. You're just translating.
Okay.
So that then if everything was centered at 0, then okay, this variable was for some row is still here, some row is still here, like that. So there are different rows of one column. These are different rows of one column, different rows of another column. But each column has an average 0. Scaling is also making sure the range of values are same. All are between some range of values between 0 to 1 or -1 to 1. More comparable.
And are these very important for every model, or
yes, they are very.
Do we need to check?
They are very important because even in linear regression, if x2 and x1 are similar variables, but x2 is in a range of values between 50,000 to 70,000. This is between 1,000 to 3,000. since even small increase in beta 2, it will assume that x2 is a more important variable than x1, but they both will be equally important.
Yeah, I think it will lead to an overfitting and
yeah, a lot of
all those concepts.
Yeah, so yeah, center scale is usually important. Yeah. Okay, cool. So yeah,
Thank you.
Cool. Welcome. So yeah, so Thiru, any other questions? We've gone through your email.
No, Pranit. All I have is I plotted each individual variable with a response variable,
Okay. Yeah.
and if you see my
Yes. Yes.
So I see age and subject have a uh, all I have is some of the columns doesn't, I don't even get a proper, it is just like, these are the only columns that I get a proper graph.
Right. Yeah. This is usually what happens in real life, most settings. What is the red line? How did you come up with the red line, by the way? Did you use any?
I used a curve.
Maybe you did a smooth. Okay. Okay.
Yeah.
Smooth. Okay, cool. So, fine. Yeah, this is real life. This is a true example of real life data set. So, this is what.
So I still have other columns. These are the only columns I could get graphs from. I couldn't get a proper visible graph for the rest of the columns.
Were the columns numerical as well, or were they?
Yeah. All of my columns are numerical.
So you didn't get, as in like some error came, or like what happened in the end?
It's just a blank screen that I'm getting. If you see last three graphs, it's kind of similar to that, but then I cannot see anything. It's like
okay. That may be an odd thing. It will be good to check the summary of that column just to see what range those values are in. And you're, by the way, plotting. You made all these plots on the same plot, right? Or did you plot individually and then copy pasted here? Like what I meant.
I used pair to get a single.
That is what I guess. So yeah. So what is happening is, if you see the range of these values, the y-axis, for example, everything is between 1 and 41. This one is the one between 5 and 55. That's in the ranges. It would have happened on the y-axis. Oh, the total UPDRS stays the same. Okay. Then the x-axis, everything is between, let's see, what's the maximum is 200, minimum is 0. So every plot has an x-axis between 0 and 200. So it might have happened for the plots that are not showing blank screen. By the way, did it show the axis or did not show the axis as well?
It showed the axis.
It showed the axis, yeah. So it might happen that it is in a range of values that is outside what R is expecting. So maybe it's completely outside of the range of values that these are in, and that's the reason it has fixed the axis somewhere, but the plot happened somewhere else. This is one common thing that could have happened. Yeah, I mean, we can bring this up in maybe next call. Just see next time, just tell me what is the range of the values that did not show up, for example. Like the PPE or DFA, some variable did not show up, right? So it would be good to see that. Or you can try without the pair, if you try just an individual plot. So you can do something called plot.mu if you're already in R. When you do it, that will clear the whole screen again. And then just do one plot at a time. So then you plot whatever your UPDRS first variable, comma second variable, first variable, comma UPDRS variable. Then it might usually show up. The pair, sometimes it sets the range. It's a cache, more like a bug in R. It kind of sets the range of values that it is expecting, and if it expects values outside that, it will obviously not show. So it is in the wrong area. So if you try just an individual plot without the pair, then it might work.
I'll try it.
Okay, cool. So, any other questions?
Pranit, this is Kamal here.
Yeah.
Quick question on the neural networks. So the initial layer and the hidden layer will have weights, and the multiplication between the weights and the variables will be done as a matrix multiplication, right?
That's right, yeah.
What if in one of the hidden layer, the number of nodes are small and larger than the number of, like we discussed, if it is a matrix multiplication,
Dimensions.
sorry, will happen like if it is not m cross n multiplied by n cross.
So
what?
Yeah, I mean, yeah, we have to be very explicit here, like in terms of mentioning the equation.
Okay.
But at high level, that issue does not show up. I mean, that's why all the neural network packs are working. But let me show Andrew, right? There's a good notation of how it is implemented internally. So, slide 14, yeah, 13 and 14. The way it is implemented internally is like this. By the way, the one-word answer is that dimension issue does not happen, and it is true. Each layer does not have to have the same number of neurons. Both are true. Like you said, one hidden layer can have 20 neurons. One hidden layer can have 2,000 neurons. It still works. So the facts that is the answer to it. But then now giving some backstory to see the internals a little more. What is happening is this: your A is the activation function that you're applying to each within. So Aij is the notation. So to a unit I, unit means neuron in layer J. So this is the layer. So that's why here you have A12, here you have A13. So second neuron in second layer. Here there's only no more second neuron, so there's only one. The third neuron in second layer. That is the Ij notation. And then basically internally the weight matrix is computed every time when you go from this layer to this layer, from this layer to this layer, which is the weighting. So A12 is multiplied with some weight that goes from that is impacted based on x2, some other weight that is based on x3, some other weight based on x1. Let's say you have 3 arrows. It's a fully connected layer. If some weight was, if this weight was 0, it is equivalent to saying this edge does not exist, which means x1 is not influencing the computation, the value in a1. But anyway, so you're computing this weight matrix again. Theta 1 means it's going from layer 1 to layer 1 plus 1, which is layer 2. Theta 2 is going from 2 to 2 plus 1, which is what he mentioned here. So then again, now breaking down what is the exact amount of multiplication that's happening. So within theta 1, 0, there is some value that hits x. X0 is like some intercept, but yeah, these are the things. This is the bias. It's like just an intercept, but this is the main things. So theta 1 is hit. Theta 1 is this matrix, but in that you have element 1 that hits with x1, which is what we were talking about then. Theta 2, 1 of first layer to second layer hits. Is what the weight coming from x2 to x1, this is x8, x1. So now you are saying if you had a different number of neurons in here, in one layer versus another layer, the problem will not happen because obviously the number of summands, like here you have 4 summations everywhere, right?
Right.
And then for A1, 3 also you have, which is the next layer. Here you have different number of neurons. This is a good example. Here 3, here you have 1 neuron. Before you apply the parallel activation. So here also you have the same number of multiplications because you 1 for the intercept and 3 to 1. You're going again from here to, if you go to another layer of 1 neuron, then you will have only 1 multiplication plus 1 intercept. Then you will have only 2 terms. Say if I put another layer here, yeah. So whatever it be, the summation number of segments will vary obviously based on how many neurons are in each layer. But then in the end, it's a sum. You get some real value on that. You apply the activation function. You got the output. That's it.
So A1
nothing will collapse.
is also kind of a matrix thing. It's not like a vector.
The matrix is only from one layer to another layer. So if you're going from 3 to 3, you have this. If you go from 5 to 3, you have another set. You have five matrices, 5 segments here. So this value is going from 5 to So none of these matrix multiplications will fail because you can always multiply matrix with a number. All this will work. The number of segments will keep changing, but that will not collapse anything.
Sure, yeah.
Cool. All right. So, any other questions? This was basically, like I said, the syllabus. Yeah, I showed it, right? So it was there to catch up. It was like a safety that I put there just in case, because we don't know at what pace we would go at where we might get stuck or not get stuck. So for now, so far so good. We've been able to cover all week 7 without any issue. We hope to finish the rest of the 4 as well without any issue. So this was there in the middle. Catch up. So what I will do is, okay. So I would recommend that you guys come push on to the project in this week as well. Hopefully there will be more progress and you'll be moving to other phases in your in this document, more and more inside, and you'll start working on model itself. I see some people have already started applying models. So we should definitely hold it by its tail and finish it at some point, because you want to put it in your resume, which is something that you can tangibly show instead of just saying I took a course in humor dogs or whatever. So in addition to that, you'll be able to have something on the resume. So let's focus on that. Next week we will catch up on the syllabus as planned. We will go through the week 9, which is and week 10, this part, and then we can back up with these another separate set of topics, week 11, week 12. I think we're on target for now. And by the time we come to week 12, hopefully your project would also be over for the most part. So that way we'd be in good shape in terms of the resume. Any other questions, comments?
Hey, Pranay, do we do any other project rather than this, like one more? Or
yes. So what we can do actually on this data set, you can actually apply and present it as two or three different bullets, where you can say you did neural networks, you did SVM, you did random forest. You can cover those 3 techniques in R. And then you can also mention, you can do a second project as well, depending on what your pace is. I'm open to having do as many projects as we can, and you're willing to do. So another thing we could do is work on somewhat of a larger data set using something called H2O, which usually runs super fast, even on like 100,000 records or like 200,000 records, a million records. So that we can give some big data angle to it. But then you can again apply neural network or random forest on using H2O, which is another option. If you want to add in, so I'm giving you some options here. If you want to add in something on data wrangling, where you're doing some slicing and dicing of data, then there is a package called DTLYR, which is very popular. You can do inner joins, outer joins, all the SQL kind of operations between data frames using that. So this will not be a project. I can squish this in as in some of our assignment, like a weekly assignment. It wouldn't be more work than that. So I will definitely squish that in, and you can although mention it as a project because you're doing all the data wrangling through it on some data set. So we will definitely do that. So that will be another mini project, if I can call it. This is very popular, kind of useful as well. So we'll have a mini project in data wrangling as part of some of your assignments. You will have 2-3 techniques that you can mention as bullets on the Parkinson's data, or you can also do something like this. Since you're doing, say, random forest on one data set that you chose, like Parkinson or whatever each of you has chosen, you can apply the second technique on another data set if you wish to. The other data set could be a smaller data set, something like Boston housing, that everyone can apply on. This will not require any incomplete imputation or anything. It's like complete data set. All you have to do is scale and center and then start applying your technique. So I would recommend all of you can have one common data set, Boston housing, for applying another separate technique. And then the rest of the techniques that you did not apply on Boston housing. So out of these three, SVM, neural networks, and nanopores, apply one technique on Boston housing of your choice out of these three. The rest of the two techniques apply on your project data set, which is whatever you chose, like Parkinson's, etc. Then we will have, so that will give you two projects with some bullets in it. Especially the non-Boston housing, the one that you're currently working on, will have some bullets because you're applying multiple techniques there. And then we will have a mini project with some data wrangling where you do some inner joins, outer join, all these things, left join, right join operations, etc. So that will give you that. And then if time persists, we can also do the H2O our project, which is applying it on a much larger data set. We can also share one large data set with at least 100,000 rows or more, and we can apply on that. So that will be like a big data version that you're doing through R. Any other questions? Would you like to do more or less comments? This is open to be tuned based on requirement. But at the least, what I've suggested, it's always good to have. I mean, if you do data science, you have to have some machine learning project that you're doing currently, which is good. Okay. All right. So you can feel free to email me as well if something comes up. So let's call it today. Have a good weekend. Do focus on your project for now. Yeah, the more the progress we have, we'll have more time for doing other things in the coming weeks. So, all right. Have a good one. Bye-bye.